Hey guys, hello and welcome to a new video. This time the case for the International Women's Day battle. It's a case between for the different local chapters to celebrate the great women we have in our community. And yeah, I think at least the German chapter you win a or you were able to win a place in the competition directly in the German competition directly for the finals if you won there. But yeah, find the thing the woman is famous for. So in basic XLOOKUP for the name returning known for, and then this is in basic mid. I'm not 100% sure if you should return this as a number. No, return it as text. Okay. Then here is the batch code, and after the backslash there is here it is. There is the weight in kilogram, or in this case in gram, and now make it in kilogram. And then we want to have the difference between this weight here and the target weight, and this then in gram, so multiply with 1000. And round. Here we go. Now switch out from the DNA string every base against the base pair. So mid sequence len 1, and then basically do an XLOOKUP for those base letters returning the pair letters, and then concat everything together. Here we go. Looks great. Now here, for each compound dose and light wave combination, find the matching records on the compound tab. So what I first did was, since this is here in another format as here, I first concatenated this with commas in between. And then did. And you also should note there might be multiple of this. So equals filter, compound data. Let's first take the effectiveness, if this is what we're searching for. And then we take the average of this. And we take the average of the side effect. Yes. And then our score is around effectiveness minus 0.6 times this rounded to the nearest number. And yeah, we could have also written everything in a single formula, but this is also equally possible. Now, okay, one sec. Okay, I had to open my macros. This is let's take this. So previous step number, I would have been able to do this in not model this out, but yeah, I think modeling this out is better. So sequence, the maximum is 100. So we model it for the sequence 100 here. It's on 97. And our starting value is given here. And we do the following. We make starting value minus this one if two conditions are fulfilled. Condition 1 is it should be then the result should be larger than 0, and the result should not have been a previous result, including the starting value. So if this is larger than 0, then if this is, I think I need a bracket here, and if not is number x match this in here, then otherwise plus. Yeah, I know, not the most efficient formula, but then we track this down and we came to 59, which is right. And example 6, yeah, and then basically this is the last result here, and we can work with this. And everything solved. So level 7. So the princess of the empress, Szepesi of Austria, is traveling between the countries, and here she is visiting the nearest available castle in the country she's traveling through, but she's never visiting a castle twice. So yeah. So what I first do is to call of the distances and to call of this and this. So these are the distances and the different castles she's traveling to. Yeah, let's also data table this. So she's starting here. I think there are no countries with two names. No, nothing with a space in between, and then text split. Row delimiter, and okay, we can also do it that way. So, and now we want to have all castles that are in Austria. Castle if this equals Austria. And previous castle and semicolon, or no, let's do it differently. Let F and then previous castle and comma at F, and then we do an X lookup for this in here, returning the distances here. And then this is distance, x lookup min of d in d, returning f. Okay, now we have only included the first condition. Now we also should include the next condition, and the next condition is that we, let's do a different filter. ff filter f if not is number x match f in one of the previous castles, and we then track this down. And then use here ff and here too. And where is somewhere she traveled a lot? I think 110. Yeah, okay. That's the maximum. Example 7, 8. And then we use to call. And for the distance calculations, we use this and drop one and drop -1. 7b, yeah, and x lookup for those in here, returning the distances, and then sum. Is this? Oh no, this is example 7a, that's the problem. Okay, yeah, if I have multiple examples, then it's have to rework this before. Okay, yeah, that's right. Let's go to the bonus questions. In the famous woman tab, more women were born in one country than in another. So basically, most of the country, count A, -2. In this case, UK. Which country? UK. For each woman in the famous woman tab, find the letter or space in their name which can be found at given bonus 2 letter. Combine all letters. What is the phrase? So here, this is basically the mid section, and this is then the start number and the case letter, and then equals concat upper of this. What is the average weight of all casks in level 3 excluding the example? Give your answer in gram round to the nearest whole number. So average excluding the example, so equals sum, average of this times 1000 equals round join all the DNA strands inputs from level 4 in order to make one very long strand. One letter appears more often. How many times does it appear? What was inputs? So cat of the inputs, and then len of this minus len substitute um 112. For each of the starting values from 1 to 100 inclusive, generate the next 1000 terms of okay. Starting values are given. Okay. B5. Number of steps is 1000. Starting value is given sequence 100, and this is max of this area here, and this is this what is entered here. B4 to calculated, and then the maximum of all of this. Yes, and we're done. I think less than 20 minutes. Cool case. I think level 5 and level 6 and 7 are quite similar, but anyways, interesting and doable case. And yeah, let's find out. I think, yeah, who will win. Thank you for your attention. I hope to see you next time. Bye.